All right, here we are. Are you ready for Math 30-1? These are the examples. So anything we didn't have time to do in class, I'll give a full detailed explanation of these. So let's just start off. Nobody really cares how you factor. The idea is just to have a correct factorization. And I don't have my pen set. Hang on. There we go. Okay. Equals. So we need two numbers that multiply to 6, and because of the minus sign, they have to differ. The difference between them has to be 5. So the only numbers are going to be 6 and 1. Sorry, a little shaky, and there's a whiny dog in the background, but what are we going to do? So we got a squared minus 1a plus 6a. So plus 6 will give you plus 5a, and then minus 6. And yeah, I did just go change the pen size. So one of the most important things when you factor is always make sure that you check your result, right? So a squared minus 1 plus 6 is plus 5 minus 6. A lot of times you'll have the right numbers here, but you may have the wrong sign and end up with a negative in there. And sometimes you just have the wrong numbers. You've got 3 and 2, and you realize that they have to add to 5 or subtract to 5. And you've got them here because we're doing a difference. We would end up with a 1 in the middle if we had a 3 and a 2 there. Okay, next up. So the only possibility is to have a 3m and an m. So I need two numbers that multiply to 6. Because they're negative, one is plus, one is minus, I need to end up. So I'm going to go with 3 and 2, and I'll go with plus 3 and minus 2. So I get 3m squared plus 9m minus 2m, which will give me the plus 7m, and then minus 6. Okay, and basically that's all you have to do on this one. My method is guess and check. Nobody cares how you factor. Just make sure that after you factor, you've checked and that you've got a correct factorization. Okay, so the first two you don't really have to show any work, and in this next one we do have to show some work. There's a greatest common factor that comes out first. It's going to be negative 2 and the highest power of x, which is actually the lowest power of x, so negative 2x squared. And then, so to get the negative 2, I've got it to get x to the 4th. That'll be x squared. That's a plus. This will be a minus. 20 divided by minus 2, so 10. That's got an x cubed. I'm going to put an x there and nothing else. And then that's a minus already, so this will be plus 24. Now anytime you factor check, so let's just do a quick check through. Minus 2x to the 4th plus 20x cubed minus 48x squared. And now we're ready to ask, does this factor? So don't forget, first factor is there. Need two numbers that multiply to 24. Because of the plus, they add to 10. Because of the plus, they both have the same sign, and that sign must be negative. And there we go. And if I'm going to check this, so I already checked, was this the correct common factor? Yes. And now let's just check this. X squared minus 4 minus 6 is minus 10 plus 24. Here, dragging the pen along, recognize this. This is a difference of squares. Both of these terms have square roots. So you factor it as the square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term. Check it over. 9p to the 4th minus, 9p squared minus 6p plus 6p, and then minus 4. This guy is good. First, there's a common factor. The x minus 3 is actually a common factor here. And we're left with 100x cubed minus. So the only time we show work in factoring, really, so here there's no work shown, you don't need it, but the time to show work in factoring is if you're doing a common factor. When you're taking that out, you need to show your work. And if we look here again, we've got another common factor, which is x, and not just x, but actually 4 goes into that, so 4x. Now that's a monomial, the 4x, so we're just going to put it out front. And then we've got the x minus 3. And then, well, that's going to be a 25x squared minus 9. So, does this factor, right? So the idea when we're factoring is we just keep factoring until we can't anymore. This is the difference of squares. And so we've got 4x, x minus 3, 5x plus 3. And the reason I always do the plus part of the difference of squares first is that sometimes, because that's a minus, sometimes this could be another difference of squares. That's not going to happen here because that's a square, but it would happen if we did have a fourth power. So we just got to look out for that. On to linear functions. We've got a couple of questions here. Determine the equation of each line. And so determine means show your work, right? And that's only something you could see on a written question where you actually have to show some work. Determine the equation of each line in slope y-intercept form. All right, so that's the y-intercept, right? I've got the y-intercept here. So I know that b is equal to -3. b equals -3. And the slope of the line, well, let's just get to another point. So from here, we go up to right 1. And so our slope is 2. So y is equal to mx plus b, y is equal to 2x minus 3. Now I want that in general form. So general form is always equal to 0. So and a, b, and c in general form have to be integers, right? So if we did have a fraction in here, the slope, if the slope is a fraction, we would have to get rid of that fraction, turn it into an integer. So 2x, and always a is greater than 0. So a, b, c belong to the integers, and a is greater than 0. Okay, so 2x, move the y over, it becomes minus y minus 3 equals 0, and we have the general form equation for this line. Okay, here we have a point and a slope. So we're going to use the point-slope form of the equation of a line. And you should be pretty familiar with this one from previous math courses. So y minus y1, so y1 is -1. So y minus -1 is equal to m. Okay, so that's our slope, -2/3 x minus, and in this case, x1, that's the 5, x minus 5. All right, simplify, we got y plus 1. Wanted that to be equals, y plus 1 equals -2/3 bracket x minus 5. So you might ask, are we there yet? No, well, we don't have slope form. So in order to go for slope y-intercept form, we're going to have to distribute the -2/3 through this set of brackets and then move the 1 over. Okay, so y plus 1 is -2/3 x. Okay, negative times a negative. Think of this as 5 over 1, right? So we'll get plus 10/3. So 1, well, 1 is just 3/3, right? And we're going to move that over. We'll subtract. So y is equal to, I might want to plug in. Hang on, I got to plug in. All right, that was in the other room, but I've got it. We're good. Let's go on. -2/3 x. So we said this is 3/3. It's plus. We move it over here. We're going to subtract 3/3, so that'll be plus 7/3. Now, we want to write this in general form. So general form, we can't have any fractions, right? And so our denominator here is 3. So we're going to multiply everything by 3. So 3y is -2x plus 7. Okay, the a's got to be positive. We're going to kick this over. So it'll become positive 2x. Then the 3y is on that side, and then the plus becomes -7, is equal to 0. And there we go. That is our general form. So we've got our slope y-intercept form here, slope form, we got general form here. Got our slope form here, got our general form here. Okay, next up. Algebraically determine the x and y intercept of, and we've got this equation. Alright, so every time I do one of these guys, I always start off by saying, hey, if I want to find the x-intercept, what is it that makes technical difficulties. All right. Algebraic determine the x and y intercept. So the x-intercept, we set y equal to 0. So let's just take exactly what we have here. And we'll go 3x minus 4 times, so you set y to 0, is equal to 16. 3x is equal to 16, and x is 16 thirds. And you notice it wants it as an exact value, and that is an exact value. And the y-intercept, okay, so to get the y-intercept, we set x equal to 0. 3 times 0 minus 4y is equal to 16. Negative 4y is 16, and y is negative 4. Okay, so that is our y-intercept. Here is our x-intercept. Here is our y-intercept. Determine. What does determine mean again? And this algebraically determine, right? Means using algebra. Determine the point of intersection of the lines. Well, sounds a lot like we are solving a system of equations, right? So let's call this equation 1. We'll call this guy equation 2. Now, it really isn't set up to solve by substitution, because for substitution you need to be able to get one of the variables by itself. So in this case we're going to have to either make the x's the same, in which case they'd both have to be 10, or the y's both 6. So I think we'll go with, let's make the y's both 6, so we'll multiply number 1. We will go 2 times equation 1. So 4x minus 6y is equal to 30. And to get this to be a 6, we're going to have to multiply by 3. So let's go 3 times equation 2, which will give us 15x minus 6y is equal to 30. And seeing as both these guys are the same sign, we're going to subtract. So 4 minus 15 gives me a negative 11x. Negative 6 minus negative 6 becomes negative 6. Well, negative 6y plus 6y, which is 0. And 30 minus 30 is 0. And then it's always at this point we go, something's wrong, because that means that x is equal to 0. And there's absolutely no reason that x cannot be equal to 0. So if x is 0, let's find out what y is. So we're going to substitute 0 for the x value in, and it really doesn't matter, so I'm going to go in number 1. So 2 times 0 minus 3y is 15. Well, that's just 0. So negative 3y is 15, and y is negative 5. So we're saying the point of intersection is, right, and this is an ordered pair, right, it's an x, y, 0, negative 5. It is a point of intersection. This is a point, right? Number, comma, number, and enclosed in parentheses. Which means this point, this value of x, this value of y will satisfy both equations. So 2 times 0 is 0. Negative 3 times negative 5 gives you 15, so that works. 5 times 0 is 0. Negative minus 2 times negative 5 minus negative 10, which is 10. All right, so we're good. It works. Let's go on. Moving on to quadratic functions. Given the quadratic function, so this is like what? Seems like half of the 20-1 course, doesn't it? Quadratic functions. Y is equal to 2, bracket x minus 1, quantity squared minus 6. State the direction of opening. Okay, so A is positive, and that means this quadratic opens up with a vertical stretch factor of 2. Whether the graph is narrower or wider, so if you're stretched vertically, this is your original. If you're stretched vertically, then everything kind of comes up and doubles, and you're going to end up narrower. Coordinates of the vertex. Well, this says that you moved x minus 1 is right 1 and down 6. So 1, comma, negative 6 is where your vertex is. Equation of the axis of symmetry. The axis of symmetry runs through the x-coordinate of the vertex. Remember, that is a vertical line, up, down, and so the equation is x is equal to 1. The range, well, it opens up, and therefore its vertex is at the bottom. It's a minimum. Actually, if we kind of sketch this guy out, we got 1, negative 6. We got this. We are going to find the x-intercepts, right? And x-intercepts don't read nicely off of this, so that's going to take a bit of work. But, you know, hey, here's a sketch. There's my negative 1, 6. Here's my axis of symmetry. X is equal to 1. And the range. Well, the range is going to be the set of all y's such that y. And we've got to be very formal. Got a diploma exam coming up. So the set of all y such that y is greater than or equal to negative 6. And y is an element of the real numbers. Max or min y value, and the value of x when it occurs. Well, okay, this is the minimum. So it's a minimum y value. Minimum y value of negative 6 when x is equal to 1. X and Y intercepts. All right, same deal, right? So the x-intercept occurs when y is equal to 0. So x-intercept, set y equal to 0. All right, and I've bumped the equation off the page, but I can still see it. But I'll write it down. So it never hurts to, you know, we're further down the page here. It never hurts to rewrite the original so you don't have to refer way up here somewhere because I can't even see it. Well, you can't. I can. It's just barely. My frame is off a bit. I wonder if I can move the frame a bit. Yeah, we'll reframe things. Okay, set y equal to 0. 0 is equal to 2, bracket x minus 1, quantity squared minus 6. Okay, kick to 6. 6 is equal to 2, x minus 1 squared. 3 divided both sides is x minus 1 squared. We want to get x. So we are going to square root both sides. Most important thing when you square root that number. And I've also flipped the sides, so left is right, right is left. So x minus 1 is equal to plus or minus root 3. Okay, never forget when you're taking the square root of a number, it's plus or minus. So x equals, and needless to say, I don't know, we said it here, but needless to say, we are going to do exact values. So you have an x-intercept at 1 plus root 3. Now root 3 is like 1.7-ish, so that's going to be like 4.7-ish, and then 1 minus 1.7 would be negative 0.7, so that probably should be a smidge over there, but it's just a sketch. It's holding some information. Dangers of the home recording studio. All right, the y-intercept, y-int. set x equal to 0. I already got that over here, so we're just gonna do this here. Y is equal to 2. 0 minus 1 squared. That doesn't hurt to show more work than you might think you need to, right? I mean, it's a lot less confusing because we can see, hey, you're substituting in. I see where you substitute in the x value. Negative 1 squared minus 6. So negative 1 squared is 1. This would be 2 times 1 minus 6. So 2 minus 6, and y is equal to negative 4. So the y-intercept will be here at negative 4 if I had to label it. There it is, all nicely labeled, and that is a quadratic. And speaking of quadratics, here's another one. Determine the equation of a parabola with a vertex of negative 3, 6 that passes through the point negative 1, negative 2. And I would always ask, what might you want to do? And what we might want to do is just sketch this out. Let's just get an idea. What does this look like? And one of the reasons we do that is when we do get our equation, is our equation going to look like, is it going to match up with what we've drawn here? Like, does this open up or down, or I don't know. Let's find out. So I got a vertex at negative 3, 6. Okay, so we'll call that negative 3, 6. So I got an axis of symmetry that runs through here. At x equals negative 3. Passes through the point negative 1, negative 2. Okay, negative 1, negative 2. That's there. So the only way that's happening is if this opens down. Like so. Which tells us that our a value should be negative, right? If we don't get a negative a value, then we've made a mistake somewhere. Write the equation in vertex form. And actually, that's the clue. Is like, how do you actually do this problem? Well, you start off with the vertex form here, and you say, what do I know? I know the vertex. Okay, so I can substitute in 2. Actually, I'll just rewrite the vertex form. And the vertex is going to be at PQ, right? So P is negative 3, so it's going to be x minus negative 3. So we're going to get y is equal to a x minus negative 3, right, which is x plus 3 squared, plus 6. So PQ, right? This is P, this is Q. All right, what else do we know? We know a point. So into this equation, we're going to substitute the point negative 1, negative 2. Negative 2 is equal to a negative 1 plus 3 squared plus 6. And what we're going to do is solve for a, which we know, based on this, has to be negative. Well, let's find out. Okay, 6, that can come over there. Go. So negative 8 is a. Negative 1 plus 3 is positive 2 squared. Negative 8 is 4a, and a is negative 2, which is good, because we think it's supposed to. So now we know our a, right? And this is the one thing we were missing in the equation here. So in vertex form, y is equal to negative 2, x plus 3 quantity squared plus 6. And in simplified form, we just basically have to expand this all out and collect it to get it into simplified form. So let's do that. Negative 2. X squared plus 6x plus 9 plus 6. Negative 2x squared, so remember we're distributing, minus 12x minus 18 plus 6. And then collect negative 2x squared minus 12x minus 12. And if I had plotted these two, so if you got your graph calculator out and you graphed this and you graphed this, they would be the same line. Okay, and I'm not going to do that, but that's something you can do if you want. Oh, you know what? I'm going to do that. What the heck? Because it's also a chance just to show you the graphing calculator. so hang on. Let's go to y equals. Let's clear out what we've got in there. Clear. Okay, so I want negative 2. Let's see if I can make that fit. There we go. So y is equal to negative 2 bracket x plus 3 bracket squared plus 6. And that'll be the blue graph. The red graph will be negative 2x squared minus 12x minus 12x minus 12. And I'm going to go zoom standard. So the standard window is going to go from negative 10 to 10. And from negative 10 on the bottom to 10. But it'll show us these points. We'll get the vertex in there and stuff. All right, so graph. Oh, wait. So I'm going to go zoom standard to get the standard window. And I got some points lying around from a previous graph. So the red line should draw on top of the blue line, which is good that it did. And then that's just an artifact left over from some other stuff. Ignore that. It's not there. You're seeing things that aren't there. Quadratic equations. All right, that's like the other half of Math 20-1. Right? I forget what goes in the third half, but the solution to ax squared plus bx plus c equals 0 is given by the quadratic formula. Okay, which you can sing to the tune of Pop Goes the Weasel, and I'm not going to. And this quadratic formula is going to be on your formula sheet anyway. So x equal to negative b plus or minus the square root of b squared minus 4ac all over, which means all of that, over 2a. The expression b squared minus 4ac, i.e. that which lives under the root sign, is called the discriminant because it discriminates. The value of the discriminant indicates the nature of the roots. So the nature of the roots is what kind of roots do we have. So if b squared minus 4ac is greater than 0, if that's positive, then there is a value for this, right? So like if that worked out to, say, 16, then this would be 4, and you would be adding 4 and subtracting 4. That would give you two different real numbers. That would give you two what we call distinct or different real roots. Okay, they're real numbers. Real roots. If this guy is 0, then the answer is just going to be negative b divided by 2a, right? You're not going to add or subtract 0, so we would call that two equal real roots. And if the discriminant is negative, then we will have the square root of a negative number, and you're not allowed to do that. And we would get non-real roots, but there would be two of them because two non-real roots. So if this were a number like negative 16, right, its square root, you would add this negative 16 and then subtract it. That would give you two different non-real numbers. State the nature of the root. So stating simply involves me saying, I could just say it's this, it's this, it's this. I don't have to justify anything. Okay, I don't actually have to work them out. However, because I don't actually know what's going on here, this is not in vertex form. I can't look at it and say, oh, it's a vertex form and the vertex is like up here and it opens down, therefore it's got two real, two distinct real roots. So let's do a little bit of work. So 24x minus 32. All right, let's go standard form. Minus 24x plus 32. Okay, that's equal to 0. So it's those values of x that are going to make this 0, and we have to figure out, well, what are they? I could graph this. I'm not going to, right? But what we're going to do is we will, wait for it, we will use the discriminant. Okay, so a is 9, B is negative 24 and C is 32. So B squared minus 4AC is going to be equal to negative 24 quantity squared minus 4 times 9 times 32, which is the C. Calculator would be handy. I actually have it worked out already, so I'm not going to do that calculator stuff in front of you. Equals, I mean, this part you could just say, hey, that's negative, but I mean, we can work it out. So it's negative 576. That's less than 0. If the discriminant is less than 0, then there are two non-real roots. Okay. Solve algebraically, leaving answers as exact simplified values. All right, well, the only way we can solve anything, really, any of these equations, is to set them equal to 0. So 3a squared, so we're going to move that over, so plus 6a minus 9 is equal to 0. Now, since that's equal to 0, we can divide both sides by 3. So dividing through by 3 gives us a squared plus 2a minus 3 is equal to 0. And will that factor? So two numbers multiply to 3, so 1 and 3. And one of them is minus, which would be the 1, and the plus. All right, let's give it a shot. So a plus 3, a minus 1 equals 0. Now, the biggest part of factoring is checking. So a squared minus 1a plus 3a will be plus 2a minus 3. All right, that works. And so a is negative 3. A is positive 1. Verify graphically. We'll do that in a minute. Let's do this guy. 2x squared minus 4x minus 5 is equal to 0. So if I'm going to factor, I'm going to get a 2, and I'm going to get a 1 and a 5, and I cannot combine those in any way to get a 4. So we are going to be using the entire quadratic formula this time. And that formula is b squared minus 4ac all over 2a. And we've identified a, b, and c. Okay, or not okay, but we're just going to go on here. So we got the 4. So negative b would be negative negative 4 is 4, plus or minus. Remember the b is negative. Let's put that in parentheses. Remember to square that negative. All right, let's see what we get. 4 plus or minus the root. So negative 4 quantity squared is 16. This will always be positive. Minus a minus will be a plus, so we're going to get plus 40. And 2 times 2 is 4. One thing to watch out for is just make sure that the root sign extends out. You're covering this entire expression here. So, let's see what we got in here. It will be 56 over 4. Now, 56 is 4 times 14, and so we're going to change this to a mixed radical because we have to simplify the expression. So 4 times 14 means the square root of 4, so 2 root 14 all over 4. And since this, they're all divisible by 2, then we can, in fact, divide them all by 2. 2 plus or minus root 14 all over 2. So we have two distinct real roots, 2 plus the root of 14 divided by 2. So we're going to graph these. So let's just take a look. What root of 14 is going to be around 4. A little bit below. Let's call it 3.5, 3.8, whatever. So 2 plus something smaller than 4 would be 5. let's call it like 5.8 divided by 2 is about positive 2.9. It's around positive 3. And we've got 2 minus, again, about 4 would be about negative 2 divided by 2 is negative 1. So not that big. So about negative point something around 1 and around positive 3. And it opens up. All right. So having said all that, I guess let's check that one first. You know, I'm just going to reset second, mem 7, left arrow, enter 2. We'll just reset the whole shebang. All right, so y equals 2x squared, 2x squared minus 4x, and I'm not going to do the equals 5. I'm going to just do the minus 5. We'll find the zeros. So the window is going to be set to the default window. And we said somewhere around 3 and somewhere around negative 1. There's the negative 1. There's the somewhere around 3. I could do a second calc of the 0. Let's just check one of these guys too. Which one do you want to do? Do the positive one. Enter, and then it wants a right bound, so we have to cross through 0, and then it wants a guess. There's your guess. So it says x is 2.8702087. So here, let's get out, quit. Okay, so if I hit x, actually, it's going to give me the number. And now, what if I do, so that would have been the plus part of this, right? So what is, I'm going to go bracket 2 plus root 14, and we'll kick out of the root 14, close the parenthesis because it's that expression that has to be divided by 2. And surprise, there we are, they're exactly the same. Okay, so that one worked. You know what, let's do the other one, but we'll we'll do a left side, right side on this one. So the left side, so we've got 3, now we have to use x, so 3x squared plus 8x minus 9, okay, that's the left side, and the right side is going to be 2x. So I'm going to graph these two equations, and the solution will be, so let's take a look. We're going to have a quadratic and a linear, right? And they're going to intersect where the x values are negative 3 and positive 1. Let's do it. So the line's going to come through there at negative 3 and there at positive 1. Now to see that, if we go second calc intersect, so I'd like to just move to about the point of intersection, then we hit enter 3 times. So there's the 1. And another way, because they're integers, we could just go look in the table, right? So we can see that at 1, the two y values are the same, and also at negative 3, the two y values are the same. Let's get out of that. Let's pop this down here, and let's move on. Exponent laws. All right, let's keep going. So exponent laws, powers. Powers are comprised of a base and an exponent. This whole thing is called a power. There's your base, there's your exponent. Radicals are composed of a radicand, the thing that we are taking the root of, and what root is the index tells us what root, and the radical sign says we are taking a root. Product of powers. So the first exponent law, if you're multiplying two powers with the same base, then we add the exponents, m plus n. So it'll be 3 to the 2 plus 4, or 3 to the 6. So it'll be 3 to the x plus 4 minus 2x. So it's going to be x minus 2x will be 3 to the negative x plus 4, or 3 to the 4 minus x. Quotient, when you're dividing powers with the same base. So the proviso is the base has to be the same. we subtract the exponents. This is 6 to the 8 minus 2, which is 6 to the 6. This is 6 to the 8x squared minus 2x, and no further simplification. Power of a power, we multiply the exponent, so it's a to the m times n, or just a to the mn. So 3 to the 2 times 4, which would be 3 to the 8. And the thing here is treat this exponent as if it's in parentheses. So it's 3 times 2 to the 4 plus x, which is 3 to the 8 plus 2x. So you have to use distributive law and distribute the 2 through the set of parentheses. Power of a product is just each individual brought to that power. So this is 2 cubed times 3 cubed. And often what gets forgotten here is that's 2 to the 4th times x to the 4th. So remember, that's a 2 to the power of 1, so it's 2 to the 1 times 4, which is 2 to the 4th, and then x. Well, there's also an exponent of 1 there. Power of a quotient, so the denominator cannot be 0. And that's a to the m over b to the m. So it'll be 3 cubed over 4 cubed. So it'll be x cubed over 4 cubed. Now, I mean, these can all be evaluated, right? We don't have to here. That'll be 64. That'll be x cubed, and 4 cubed is 64. Zero exponent. If you have a zero exponent, as long as the base is not 0, that's 1. It doesn't really matter what's in here. That's 1. And again, it does not matter what's in the parentheses. Raised to the zero exponent will be 1. Negative exponent is 1 over, and then you make the exponent positive. So this will be 1 over 5 squared, right? That's why a can't be 0. You can't put a 0 down there. This will be 1 over x squared. In a fractional exponent, the denominator tells us what root we are taking. It is the nth root of a to the m, or it is the nth root of a, then raised to the exponent m. So if you have a calculator, regardless, it doesn't really matter which way you do it. Without a calculator, it's often easier. Let's find the root, and then we'll raise it to the power. So this one, I'll actually evaluate this one. So it's the square root of 9. Now, I don't want to put the cubed here. I don't want to do the square root of 9 cubed. I'm going to do the square root of 9, and then cube that, which will be 3 cubed, or 27. If you do it the other way, you can have the square root of 9 cubed, which is the square root, and you don't need the index if it's the square root of 729, which we probably don't really know is 27. And this is a product, so it's going to be 9 to the 3 halves x to the 3 halves, right? Or do the square root of 9x. Square root of 9x, all cubed. I'm going to simplify it. It's the square root of 9, which would be 3 times the square root of x cubed, or 27, right? Which we already know from here. 9 to the 3 halves is 27. And then square root of x cubed. And we can throw the cube down there. Simplify, express answers with positive exponents only. Okay. So p to the 4 plus 10. Multiplying, we add the exponents. P to the 14 over p to the 11. We are dividing, we subtract the exponents. And we get p cubed. Now, if you want to go there directly, you can just say it's p, so I'm multiplying, so 4 plus 10, and then I'm dividing minus 11. Okay, that'll take you right there. In this expression, deal with the numbers first, so we have negative 8, and then the d, that's going to be 5 minus negative 2, so negative 8 d to the 7th. What do we got here? We've got 5 times negative 2 is negative 10x. Okay, and we add the exponents. 3 halves plus 5 halves is 8 halves. Let's put equals in there. Negative 10x to the 8 halves, which is negative 10x to the 4th. Here we have to cube first. So negative 4 cubed a to the negative 2 cubed, and then 8a to the 7th. So negative 64 a to the negative 6. Let's get some equals in here. 8a to the 7th, negative 512 a to the 1. I'm just going to do it this time. I'm not going to write it down. It's negative 6 plus 7. You can just work it out. Convert each following to radical form and then simplify and evaluate without using a calculator. So 1/3, well, the bottom number tells us what root. So we are dealing with a cube root, and the top number is a power, so it's just the cube root of 125, which is 5. A negative exponent. So here's the easiest way to do this is we'll change the negative exponent to positive, and when we're dealing with a fraction or rational, when you change the exponent negative to positive, things are going to flip around. So we'll just flip it x squared over 64 to the positive 1/2, which will be the square root of x squared over 64, which will be x over 8. Oops. Drag that down. Express each of the following as a power. So now we change from, so this is a square root. There's a 2 there. So it'll be x to the power of 1/2. So it'll be 5. Okay. What root? That goes in the denominator. What power? Numerator. So it'll be 5x over x to the 3/4. Okay, that tells us we want the 4th root, and that's cubed. That's an x to the 1. X to the 1 is 4/4 minus 3/4. So 5x to the 1/4. Radicals. Simplify and write with a rational denominator. We always rationalize the denominator. So nothing we can do with 8 root 2, that doesn't simplify, or 2 root 3, but root 18. So root 18 is the root of 9 times 2, which is root 9 root 2, which is 3 root 2. Now you can go directly there. You can just look at root 18 and just go directly to 3 root 2. So 8 root 2. Plus 2 root 3 minus 15 root 2. So let's go with the positive term first, which will be a 2 root 3, and then we have minus 7 root 2. Okay, we're just going to leave that. There's no denominator to rationalize here. With the radical in the denominator, we multiply the numerator and denominator by this radical. So 2 root 5. Root 5 times root 5 is 5. 3 times 5. 2 root 5 over 15, and no further simplification. Binomial denominator, we multiply by the conjugate, which is the exact same two terms, but opposite signs. So numerator, this turns this into a difference of squares on the bottom. So up top we get 21 minus 7 root 5. And here, this just becomes 3 squared minus root 5 squared, right? So 3 squared minus 3 root 5 plus 3 root 5. The middle terms go away. So 21 minus 7 root 5 over 9 minus 5. 7 root 5 all over 4. And the only way that this could have been simplified is if this, this, and this were all divisible by the same number. So if this had been a 3, that would have gone, oh, never mind. If it had been a 7, then we could have simplified, but we can't simplify this any further. Solve each equation algebraically and then verify your answer graphically. So if you want to solve a radical equation, the idea is to isolate the radical and then square both sides. So let's get the 12 over there. Let's get the radical isolated and let's square both sides. And then, so negative 2x will be 11 and x will be negative 11 halves. The radical is isolated, so we square both sides. Now you're squaring a binomial, right? So really what we want to do is this, 2x plus 1 times 2x plus 1. So we're going to get 4 products, right? FOIL. So we're going to get 4x squared plus 2x plus another 2x. So it's going to be plus 4x plus 1. So to solve this, it's got to be equal to 0. So this minus x comes over here. It's going to give me a plus 5x. And we're going to subtract 7 from both sides. Minus 6 is equal to 0. And then we'll see if they were nice. And this is factorable. Let's try 2 and 2. So I put a 3 there, I'll get a 6. And I put a 2 there. Nope, you know what? Let's go with a 4. Let's go 4x and x. And then if I put a 2 there, I'm going to get an 8. And I'm going to put a 3 there. So we'll have an 8 and a 3, right, which will give us a 5. And I want that to be plus. So we'll put a plus there. We'll put a minus there. Nobody cares how you factor, right? Just check it, right? 4x squared plus 8x minus 3x is plus 5x minus 6. It works out. So it means that 4x minus 3 is equal to 0. 4x is 3, x is 3/4, or x plus 2 is equal to 0, and x is equal to negative 2. Verify your answer graphically. I'm not going to do that, but if you want to go ahead and graph them, then you'll see that they should work. Although, actually, let's be careful on this one, because we've got a root, and I want to make sure one of our solutions doesn't give us a negative. So let's just try this algebraically. 7 minus negative 2 is 9. The square root of 9 is 3. 2 times negative 2 is negative 4. Plus 1 is negative 3. So actually this is not a solution. So we're going to have to cross it out. It's extraneous, right? Since it's negative, it's going to make this side negative. But the left-hand side, being a radical, has to be a positive number. So this one should work, because this will be positive. 2 times 3/4 will be 6/4, which is 3/2 plus 1, which will be 5/2. This will be 7 minus 3/4 is 6. So minus 3/4 is 21. No, 28. 25/4, which is also, that's what this is going to work out to. This one should be okay because you're subtracting a negative here, but it's a good idea to either graph it or somehow just to check it over and make sure that you're not introducing extraneous solutions, which is what this guy here was. Rationals. Simplify and state non-permissible values. So the first step is to factor denominators, state the non-permissible value. We generally state them as restriction. So we say x cannot equal, so x can't be 3. Okay, and what we want to do is factor everything. So it'll be 3 plus x. This will be 3 minus x over x minus 3. And these guys are almost the same, except this has a positive 3 and a negative x. This has a positive x and a negative 3. So if I put like a negative 1 in front of the brackets here, I can flip these around and make that an x minus 3. So basically, here's the deal. Short form. If you have an x minus 3, you can cancel it with a 3 minus x. You're just going to write in a minus 1. So this works out to negative x minus 3. So that's simplified, and the restriction still holds, right? The non-permissible value x cannot be 3. So whatever you can't have value of x in the original, that can't. You can't all of a sudden just put a 3 in there, right? Because 3 would work in here. You'd go negative 3 minus 3 and say, well, that's negative 6. But when you put 3 in here, you're trying to divide by 0, and that's not allowed. All right, let's do this by steps. So the first step is you factor everything, numerator and denominator. So this is going to be a 5x as a common factor and a 2x minus 3. And all right, here, I'm willing to bet that one of the factors is 2x minus 3, just because that way these guys are going to cancel. If it is, I'm not saying it is, but if it is, that'll be an x to get 2x squared, and to get minus 15, this will be a plus 5. So we didn't actually factor that, we just sort of said if that's a factor. So let's check this. 2x squared plus 10x minus 3x is plus 7x minus 15. Okay, now we can state the non-permissible values. So it can't be negative 5, and it can't be positive 3/2. Now, the easy way to do this is you just take this number with the opposite sign and divide it by this. So this number with the opposite sign is negative 5 divided by 1. But, I mean, in essence, what you're doing is that you're saying 2x minus 3 is 0, right? Because we want it not to be 0. So 2x equals 3. That's the opposite sign of this. And then divide it by whatever's in front. That's the quick way, right? Opposite sign of this over this. Those are our restrictions. So anytime we're working with rationals, we have to be very careful, pay attention to these guys. And then simplify. We crossed off out, put a little 1 there. So 5x over x plus 5. Oh, sorry, I ran off the tablet. These do not cancel. Okay. Some people are going to think they do, and if they did, this would just be 5 over 5 or 1, which would say for every x you want to put in there, you're always going to get 1. And that's, of course, not true, because if x is 2, you'll get a 10 over a 7. All right, let's keep going. Solve rationals algebraically. So you have a rational equation. You want to solve that. So step 1 is figure out your non-permissible values, especially here, because if we're solving for values of y, which is what we're going to end up doing here, and then we need to check them at the end just to make sure that they actually work, that they're allowed values in the expression. Sometimes the act of solving will introduce extraneous values. So y can't be negative 3, and over here it can't be 0. What I like to do is state the lowest common denominator. So we've got a y plus 3, we got a 2y, and we've got a 5. So in order to solve a rational expression, you're going to multiply everything by the lowest common denominator. So I'm not actually going to show all of that. Just say, well, when this is multiplied by this lowest common denominator, you're going to get the 2. Wow, okay, you know what? Let's show it all. Here, we'll do it. Clean this up. Okay, so we take the 2 over the y plus 3, and we're going to multiply that by the lowest common denominator, y plus 3, 2y, and 5, and just over 1. Since this is an equation, as long as we multiply everything by this LCD, then it will maintain its equality. Times y plus 3, 2y, and 5, plus 2 over 5 times y plus 3, 2y, and 5, again, over 1. And the idea is, when we've done all the canceling, then all that should be left in the denominator is 1s, right? And we can see we've got a 1, a 1, 1, 1, 1, 1. Okay, now we simplify. So what do we got? We've got 2. So 2 times 5 is 10, times 2y is going to be 20y. Oh, and here, well, let's see, we've got a 5, and a y minus 2, and a y plus 3. And here we've got a 2, well, you know what, it's 2 times 2y, let's call that 4y, times y plus 3. Okay, 20y. Let's multiply these two guys out. So we'll get y squared plus 3 minus 2 is plus 1y minus 6 plus 4y squared plus 12y. Okay, keep going. Keep going. So we can divide everything by 3 here. Alright, let's see if we get something that factors. So let's go with the 3y. Oh, I bet you it will. So if we throw a 2 here, then that'll give me minus 6. And then we put a plus 5 here. So we get 3y squared minus 6y plus 5y is minus 1y minus 10. I'm going to extend my page. So y is equal to, remember, so take the 5, negative 5 over 3, and y is equal to 2. Let's check those against our excuse me, extraneous values. So the negative 3 is good, 0 is good, so those should both be solutions to the rational equation. Let's graph out and see what we get. So we want negative 5/3 and a 2. So turn that on. Y equals, I'll just do left side, right side. Clear. So 2 divided by y plus 3. Okay, I got a fancy calculator here. I'm going to go alpha f1. Number 1 is numerator over denominator, so 2, and you just kick, and then x plus 3. Okay, remember we have to use x's, not y's. I'm going to do the same thing down here. Numerator over denominator. And then you go x minus 2. If your calculator's not that fancy, you can still do this. You just have to use brackets. 2x over here plus 2/5 plus, and might as well use our fancy fraction again, 2/5. Okay, so if we graph that, we'll have a red line coming. And so that kind of looks like minus 2, so let's go second calc intersect. So all I do for that is just move to about the point of intersection, hit enter 3 times. Okay, so negative 1.667, that's negative 5/3. Second calc, intersect, and that's round. So we've got 2 and negative 5/3 as our solutions, right? Let's go check that. What did we have? We had negative 5/3 and 2. Okay, so without being asked, but we verified it graphically. See, okay, all works out nicely. Thank you. All right, let me just clean things up here. So give me a second. We'll clean this up, and then we'll do the next one. All right, next up. So start by factoring all the denominators. And it's a pretty fair bet that the factorization of this is just these two guys. But check it out. X squared plus x plus 3x is 4x plus 3. Then non-permissible values. So it can't be negative 3 or negative 1. So keep that in mind, because if we solve this and end up with a negative 3 or negative 1, we have to reject that answer. The LCD is x plus 3, x plus 1. So when that happens, we'll get x plus 1 here, and the x plus 3 is going to be gone from here, so times x plus 1. This x, the x plus 1 will be gone, will be times an x plus 3. And both of these guys are going to be gone. We'll just get x minus 3. So the idea is we multiply through by the lowest common denominator. That cancels the denominator. We end up with a linear equation from a rational equation, or quadratic, a non-rational. Okay, so x squared plus 2x plus 1. So watch out here, minus x squared, and then the minus here, so minus 3x. And let's just move these over. Minus x plus 3 equals 0. That was just moving those guys. So the x squared's gone. We've got 2x minus, so 2x minus 3x will be negative x, so minus 2x, negative 2x plus 4 is 0, negative 2x is negative 4, and x is 2, which works. That's allowed, so there should be one solution in this case, which is simply x equals 2. Okay, are we there yet? The reciprocal of, God, this is like the entire Math 20 course in an hour. More than an hour. Already at an hour. Way over an hour. Graph, y equals 1 over f of x. So graph the reciprocal. The point xy that lies on the graph y equals f of x is transformed. Ooh, get used to this language, because the first unit in 30-1 is transformation, so that's what we're going to be doing a lot of, is transforming. Is transformed to the point. Okay, so the y value, so it's going to be x, and so the point xy will become the point x and 1 over y. 1 over y. Right, we're taking the reciprocal on this graph, right? So xy becomes x1 over y. If y equals f of x is a continuous function, okay, so in other words, you could draw it without lifting your pen, then y equals 1 over f of x, well, vertical asymptote, well, if this guy is 0, you're going to end up with 1 over 0 here. So it's whenever f of x is equal to 0. The invariant points, so invariant are the points that do not vary, that are the same. So when will the y values be the same? When is y equal to 1 over y? Well, that's going to happen when are the points where the y coordinates are either 1 or negative 1, right? So if you've got y as 1, this will become 1 over 1. And if you've got y as -1, this will become 1 over -1. And so those points will be the same on both graphs. Graph y equals f of x is shown below. Sketch the graph. Okay, so there's usually I'm going to change colors. There's usually a few steps we go through here. We have kind of a way of stepping through this. So the first thing is just to say, okay, where the original graph is 0, we know there are going to be asymptotes. So I'm going to, my lines are going to be thicker here, but so the first step is, I should dash them out a bit more, put in the asymptotes. Okay, so where the original graph has a 0, the black is the original graph, then the reciprocal 1 over is going to have asymptotes. Okay, that's step 1. Step 2 is we plot the invariant points. So let's do green for that. The invariant points come when y equals 1. So this line is the line y equals 1. So we just go along the line y equals 1, and we can plot the invariant points. And then the same for -1 and -1. Okay, so we've got the zeros, we've got the invariant points. We want to plot, do we have any other interesting points? Well, we've got a minimum value here at -8. The reciprocal, that's going to be -1/8. So, you know, if we can plot a few other points, that's a max or a min point, or other key points. So let's take a look at key points. So I've got like -4. Well, that's going to be negative. Well, it's here. We'll do -2. -2 is going to be like -1/2. And -2 here is going to be like -1/2, right? We can eyeball that. The -4, right? The y value will be -1/4. So again, we're going to eyeball a few points. We're just going to plot a few other points, get an idea of what's going on here. Now, I'm going to use blue. We'll use blue, and then we'll go with thin blue. I'm going to go with thin blue. Okay, so let's plot this. So here's how we do this. We say, as these y values get to be really large numbers, then when you go 1 over a really large number, you get a really small number. But these are positive numbers, so it'll be eventually 10 and 100 and 1,000. So these will become very small positive numbers. And this will just head this way. And the exact same thing is going to happen here. As these guys get really large, these guys are going to get really small, but still stay positive. Okay, now what happens as these values get smaller, 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 right? So you just think about it. This is 1, so it's an invariant point. When it's 1/2, then the reciprocal is going to be 2. When it's 1/10, the reciprocal is going to be 10. So these values are going to climb, controls it. They're going to climb the asymptote line. Do the best I can here. So it isn't actually going through that. It actually is going through it. It doesn't actually go through that line. It just runs up along that line. We'll see if we can do a better job on this side. It goes up along the asymptote line. Okay, looks a little better there. All right, same deal is happening here. So see, these guys are going to be really small negative numbers. So their reciprocal is going to be a very large negative number. It's going to go down that asymptote line. These guys here, again, really small. So that's going to go down there. And then we know what happens in here because we've drawn out a number of points. It's all in how well can draw, and that's just one line, and we're done. Okay, so what were those steps? All right, and hang on, switch pen. So step 1 was to draw vertical asymptotes. Draw vertical asymptotes through the zeros. Draw vertical asymptotes draw vertical asymptotes through the zeros, so where the original function through the zero, where the original function has a y value of 0, so through the zeros of the original function, which is y equals f of x. And the zeros on the graph, that's the x-intercepts, really, right? So you're just looking for the x-intercepts. You're going to draw vertical asymptote through them. Plot the invariant points. So step 2 is to plot the invariant points. Points. So that's where y is equal to plus, it's supper time. Yuri gets excited around supper time. So where y is equal to plus or minus 1. Third, plot the reciprocal, so the 1 over values. Oops, plot the reciprocal of any min-max points, any min or max, any min-max point, and any other nice values. Other, you know, like that 2's, negative 2's, which would become a half or a negative a half. Any of any min-max point and other nice values. Just ones that you can plot something for. Now, as y equals f of x gets larger, then you're going to plot smaller numbers, right? So as the original function, as y equals f of x, that's the original function. As y equals f of x gets larger, the reciprocal gets smaller and tends towards 0. In other words, it heads towards 0. And that it could be a positive 0, or it could be from, if it's from above, it's going to be above the 0, and if it's from below, it'll be below. As y equals f of x tends to 0, so as it gets larger, then the reciprocal gets smaller. As y equals f of x tends to 0, as it heads to 0, then we get larger values. The reciprocal gets larger. Okay, and either larger positive values heading up or larger negative values depending on the original f of x. Because the reciprocal is never going to change its sign, right? It's just 1 over 1 divided by. And then draw smooth curves and do not cross the asymptotes. So draw smooth curves. Smooth curves. And there was an actual drawing a reciprocal on the diploma a couple of years ago. Draw smooth curves and do not cross the asymptote. Do not cross asymptote lines. Okay. Okay, trigonometry, special angles. So we've got a 45, 45, 90 triangle here. Okay, where were we? Determine the exact length of the hypotenuse. Well, it's going to be the square root of 1 squared plus 1 squared, or root 2. Use the dimensions of the triangle to state the exact value. So the sine of 45 is opposite over hypotenuse. That's 1 over root 2. And most often we rationalize the denominator and write that as root 2 over 2. Cos of 45 is adjacent. So also 1 over root 2. which we generally just write as root 2 over 2. And the tan of 45 is opposite over adjacent, which is 1. A 30, 60, 90 triangle is shown below. Determine the exact values of x and y. Use the diagram below to the right. So basically, if this is an equilateral triangle here with 60, 60, and 60, and this is 1, then this must be 2. And this, well, Pythagorean theorem again. So y will be the square root of the hypotenuse, so 2 squared minus 1 squared. So y will be root 3. So this side is root 3. This is 2. State the value of sine 30. So the sine of 30 is 1 over 2, 1/2. The sine of 60 is root 3. Opposite over is root 3 over 2. The cos of 30, so 30 is opposite, or sorry, cosine is adjacent root 3 over 2. You know what the co stands for, right? This is cosine. So the co is complementary. So the cosine is the sine of the complementary angle. In other words, the angle that adds to 90. So the complementary angle for 30 is 60. The cos of 30 is the sine of 60. The cos of 60 will be the sine of 30. The cos of 60 is adjacent over hypotenuse is 1 over 2. Tan of 30, tan is opposite over adjacent. That's 1 over root 3. And again, we rationalize. So root 3 over 3. And the tan of 60 is opposite over adjacent, root 3 over 1, or just root 3. Using that, we can determine the exact value of each indicated sign. So 30 degrees, right? So we know the sine of 30 degrees. Well, let's just start off with formulas. I always like formulas. The sine of an angle is opposite over hypotenuse. The sine of 30 degrees is opposite. It's going to be y over 12 hypotenuse. So y is equal to 12 times the sine of 30 degrees, which is 12 times 1/2, which is 6. Okay, and being as there's no units, then it's just a number. Y is just 6. Again, let's use the 30 degrees. Obviously, we know this is 60 degrees, but let's just stick with the 30 degrees here. So, cos of an angle, cos is adjacent over hypotenuse. The cos of 30 degrees is adjacent, which is x over 12. X is 12 times cos 30 degrees. X is 12 times, the cos of 30 degrees is root 3 over 2. So x is 6 root 3. Okay, and again, there's no units. And we know that x has to be bigger than y. Why do we know that? Because the largest side, the hypotenuse, is opposite the 90-degree angle. The smallest side is going to be opposite the smallest angle, and so the 60 degrees there, being larger, will have a side in between 6 and 12. Or in this case, 6 root 3. Okay, what's next? So anytime you're doing trig, right, you want to name stuff. So this is opposite, this is hypotenuse. Okay, this is beside, this is adjacent. So the ratio that relates adjacent and hypotenuse is cosine. The cos of 45 degrees is adjacent, x over 20. X is 20 times the cos of 45 degrees, which is root 2 over 2. So x is 10 root 2. And we got no units in there, right? Because we got no units in there. There's no units because there are no units. Use your knowledge of special angles to determine. Okay, well, this is, so x and y are equal to each other, right? We know that. What else could we do here? Well, we could do the sine of 45 degrees. So the sine, I don't know, let's do cos. We got the angle listed here. So this is adjacent to this hypotenuse. So cos theta, adjacent over hypotenuse. Cos, I do math under, hey, here's a formula. I'm going to substitute what I know into the formula. So x is simply equal to the cos of 45 degrees, which is root 2 over 2. And y is the same, okay, because it is an isosceles triangle. And these guys, yada yada. But if you want, I mean, you could just go sine theta is opposite over hypotenuse, right? Or we could have just started here. Sine 45 degrees is y over 1. Y is equal to sine 45 degrees. Y equals root 2 over 2. Okay, what do we got here? We got 30 degrees. Let's do x first. That's hypotenuse, so cos theta is adjacent over hypotenuse. Cos 30 degrees is x over 1. X is just cos 30. Which is root 3 over 2. Sine theta is opposite over hypotenuse. Sine 30 degrees is y over 1. Y is sine 30. Y is 1/2. Cos theta, so again, 60 degrees, that's adjacent, so cos. I mean, really, what does this come down to, right? It's just x is equal to cos of 60 degrees, the side adjacent to the angle. And you're going to see an awful lot of this sort of hypotenuse stuff being 1. So x is cos 60, which is 1/2, and y is equal to sine 60, which is y is root 3 over 2. State the exact value of each of the following trig ratios. So the sine of 150 degrees. Well, 150 degrees is in quadrant 2. And in quadrant 2, the sine is positive and its reference angle is 30 degrees. So this will be the sine of 30 degrees, which is 1/2. The cos of 135 degrees, so the cosine, 135 degrees is in quadrant 2, and in quadrant 2 the cosine is negative and the reference angle is 45. So it's the negative cosine of 45 degrees, which is root 2 over 2. Tan of 240 degrees. So 240 degrees is in quadrant 3. And in quadrant 3, the tangent is positive, and the reference angle is 60 degrees. So this will be the tangent of 60 degrees, which is root 3 over 1, or just root 3, right? I mean, those values are back there. Negative 225. Okay, so if we're going negative 225, we're going backwards. So back 90, 180, 225. It's got a reference angle of 45 degrees. It's in quadrant 2. So it is the same as the sine of 45 degrees. It'll be root 2 over 2. Cos of negative 270, negative 90, negative 180. Okay, it's going to be the same as the cosine of 90 degrees. Okay, and the cosine of 90 degrees, oops, let's write that in. Cos 90 degrees, and that's 0. And the tan of negative 90, that's negative 90 degrees. Okay, it's the same as 270 degrees. So that would be the same as the tan of 270 degrees, tan of 270 degrees, and that is undefined. Undefined. Oh my goodness. It's only 6 hours to get to this point. Okay, it's about an hour and a half. So, all right, we're here. We're here. We completed the first, and it's not really a lesson. It's really just the Are You Ready for Math 30-1? Do you remember the stuff from before? And, you know, if not, well, you will at some point. So, yeah, TTYO.